I'll pass the microphone over to Claudio. Claudio, please take it away.
Hi guys, this is Claudio Farkas, Senior Solution Architect for AWS, and today we're going to talk about modern AI/ML powered by Amazon SageMaker. Just turn off my video so I have a little more screen real estate. So when we're speaking about modern, I'm looking at specifically two aspects. One of them, we want you to have access to the latest and greatest tools. And second, stop reinventing the wheel. There is already so much developed in the field, and developing new tools and new solutions or stringing together things that already somebody else did is not really the best way to spend your time. And the reason I'm saying is that if you're looking at machine learning in general, the development is rather costly and complex. You have to get your data, and that's typically something that is very difficult to do, especially in academia and education or research, where that data might come from different sources, might be of different things that you actually need. You might need to clean it up in a certain way. You might need to label it because it is not exactly what you originally intended for the specifics that you are doing. You have to find the right features, check for bias, put it all together, typically in a notebook, pick an algorithm, train a model, hope it actually works how you expect. If not, you have to tune parameters here and there. Then you deploy it in production. And again, what is production might be something different for everybody. But in the end, you still need to test that. And if you're running some sort of applications against that model, you have to monitor the performance of the model remains exactly what you expected as bringing new data or time passes by. And if you work in a team, or even if just yourself, you want to make this into a more fuller process. So if you are familiar with DevOps practices like CI/CD, then that's something that you are previously striving to achieve on the machine learning side as well. So to help you in that regard, we developed a comprehensive stack of capabilities. And we have three different personas, three different audiences that this stack is targeting. If you are interested into turnkey solutions for specific applications, such as, for instance, I need to translate some piece of text, could be a study material from English to Spanish, for instance, or I need to look at certain images and recognize they have certain elements in there, or I'm looking to create a forecast based on some original data I already have. But I'm not a machine learning expert. Machine learning is not really my thing. I'm focusing on my biology or chemistry or whatever is my field. I can use this service feature on the top with just my data. And we take care of the models themselves, making them as good as possible. We also take care of the software that runs them, scaling that software such that in the end, you get just the output which is relevant for your specific scientific need. In the middle, which is basically discussion from today, we have the SageMaker platform, which is targeting developers, machine learning practitioners that are looking to get from all the way on the left their data, which might be necessary to be labeled, to picking algorithms, training them, deploying the production, tuning all the parameters, make sure they still work as necessary, and all the way to even deploying this on edge devices. Really at the bottom, we have a layer for experts where, for instance, if you already have your own models in TensorFlow, PyTorch, RemixNet, or others, and you really want to work as close as possible to the hardware, maybe GPUs or FPGAs, you can do that. And these lines are not really a be-all, end-all. If you already have, let's say, your models written in TensorFlow, and you have not thought about the rest of the parts, like for instance, how do you deploy it in production? How do you monitor that this is performing well? How do you debug it? You can always go up to SageMaker, for instance, and vice versa. You started with our AI services to, for instance, create a translation or to recognize some entities and some text. And you see that what we are offering is not really the perfect choice for your specific field of science or for your research. That's not a problem. You can take that same data and come into SageMaker and use some of the built-in algorithms or develop your own, and again, get something which is much better aligned towards what you're looking for. So again, we are going to focus today on the central part, and specifically, we are going to show you in the demo, the SageMaker Studio, and demonstrate some of these features that you see here. Another good part, again, I mentioned very early on, is that we want you to have the same access, the same tools that everybody else, any of our customers have. That means as we are building features and we beef up the security on our services to, for instance, have the financial industry or security industry, then the same benefits you get out of the box through SageMaker, even if you're just a small investigator or an individual. So that means you get out of the box compliant with PCI and HIPAA or FedRAMP. And when you deploy your code, you can just take advantage of all those built-in features and things that, for instance, SageMaker is interfacing to, such that you can be compliant with those specific regimens. The same, you can create models which scale to massive data sets. You can orchestrate different jobs together to achieve a specific AI ML pipeline. And we see our customers using this in a number of different domains or verticals. For instance, from predictive maintenance all the way to churn predictions. In research in particular, there are a couple of fields or use cases we see more prevalent. For instance, with respect to looking at textual data or computer vision, but also personalization and forecasting. And whether you have these as turnkey solutions or you use them from the existing options that we have, or you want to use them through SageMaker to, again, develop your own custom model, we provide for you a number of built-in algorithms. And here is just a selection that we show to do, for instance, regression, anomaly detection, or feature reduction. And you can have access to all of this through our SageMaker platform. Here we have SageMaker depicted across 4 different categories. On the left side, you see the preparation, the building, then training and tuning and deployment management. Many of these capabilities are accessible through SageMaker Studio, which is our IDE based on Jupyter Lab. So if you're already using Jupyter Lab, you should be very familiar with how the interface looks like and how to navigate it. You see some of them start with green. Those are the features that we're going to discuss about in our demo. I'm not going to cover everything here. SageMaker is simply too big to go through all of this in a single hour, or basically half an hour for the presentation part. But at least it will get you started so you know where to go to learn more. And many of these have examples that are publicly available on GitHub, so you can go through them at your own pace afterwards. So we're going to talk about a little bit of data wrangler. So how do you get data into SageMaker, how to look at bias a little bit, how to use autopilot to figure out what is the right machine learning algorithm you can maybe apply to this kind of data, play with the experiments, do training and tuning of that, and then deploy it so they can validate that the algorithm actually works exactly as you expected and you have the right performance. So when we look at the studio, one of the first things that really matters for research is that this is designed for collaboration. It helps you scale and share your notebooks with your coworkers or peers that you're maybe working on together on a paper. It allows you to easily track and manage all kinds of experiments and trials that you are going through in order to find the best performing model. It has automatic model generation, and you'll see that as we're going to the demo. It allows you to achieve very high quality machine learning models by finding what are the right parameters, monitoring they perform as necessary, debugging them if you see things that, again, are not really as you expect, and then also increase your productivity, especially if you work in teams, by allowing you to build, train, deploy, and monitor through a single unified interface. Pretty much implement the same development practices that are used for regular code development in the ML world. To get you started, we actually have a number of pre-built solutions, part of SageMaker Jumpstart, and these solutions are fully customizable. So they can be used to implement, for instance, computer vision in your own images. It doesn't matter if they are started from, for instance, defect detection, you can customize the solution to apply them for a different field. The same goes for demand forecasts, or for instance, the popular one, autonomous driving. So you can take these solutions, customize them in just a few clicks, and deploy them in production. All of these solutions have all the plumbing and necessary parts from AWS ecosystem built in, such that you can get production with minimum friction. One of the first things that you'll basically see as you're starting to work with data in SageMaker is that your data is either inconsistent or is not labeled at all. And if you are doing any kind of data processing and you need to have that data labeled and you are working in a specific niche in which there is a very small number of people actually understand what you're working on. For instance, you're working on some microscopy images or you're doing some sky surveys, and the number of specialists in that field is rather small. The people actually ask for help to help you label, it's rather small. That means you have a problem with your hand that is very hard to scale. You're depending on people that maybe don't really have access to your tools. This is where ground truth actually comes into play. It allows you to define up to 30 different labeled workflows or work with these workflows to bring together a workforce of your choice to help you label that data. And it's all pay as you go. Some of this workflow include, for instance, image classification, cats and dog, basketball, soccer, and so on. Or selecting certain things in an image and saying this is, specific the location of the cat, or this is a ball, or this is a cell, and so on. Often that might not be enough. For instance, if you're doing, let's say, microscopy, you might want to highlight the entire outline of a cell. In that case, for instance, segmentations might be a better choice. And you might be dealing with video, not just plain images. And again, we have options for that as well. Or if you're doing automotive, self-driving technologies, maybe you might want to operate with point clouds from LiDAR. And again, if that's not your thing, you're working with text, you can text classification or name entity recognition. All of these are fully baked into SageMaker Ground Truth. And you can bring together 3 different kinds of people to help you. On one hand, if your problem can be solved by pretty much anybody in the world, if they don't need specialized knowledge to help you there, let's say you want them to look at satellite imagery and pick any kind of man-made structures. Again, you don't have to be an expert there. We have access to up to 500,000 independent contractors worldwide that can work 24/7 and help you label that image or those images. But on the other hand, you might be working in a specific niche where that is not the case, and you basically have a handful of people that can help. In that case, that private workforce of yourself, your coworkers, can go through your images and help you label them. Or again, might not be images, might be text, might be something else. Or it could be that you have some funding and you can actually bring in a vendor which is specialized in a specific field, and then can help you go through this process of labeling your data faster. So this is, again, how you bring the human in the loop to help you deal with the labeling part. There is also the machine in the loop that you can also bring. And here's where the auto labeling feature helps. As you have a lot of data, you can use this feature to reduce the burden on the humans that are doing the labeling and also reduce the cost. And the way we do that is that we train in parallel with the humans and the model behind the scenes. And as the humans are annotating, that model learns from and then starts making prediction. And if those predictions are having a high confidence on recognizing what the human did before, then that's passed through basically that training data out of the box. When we have low confidence in that model, on that prediction, we pass it back to humans, the humans annotate it, we continue to learn from that. And again, we reduce that way the number of images or text that the humans actually have to do and associated cost by up to 70%. So assuming that you have some labeled data, the other part is, okay, I have some data of some sort, but data typically is dirty. It means I have to go through it and clean it. If you are used, for instance, working in the biomedical field and you get, let's say, EHR data, lots of data is missing. Working on, let's say, satellite imagery or maybe pictures of the sky and you have airplanes or satellites going through and you have to go there and make corrections. That's, again, this is pretty much unavoidable in all fields of science. And then you see that you're spending a lot of time doing that cleanup and organizing, identifying things that make sense or maybe that don't really make sense, have to be removed, or might have some interpolation, other things that you might do depending on the field that you're working in. SageMaker Data Wrangler is actually your best friend here because it can help you bring in data from various sources, such as Dina or Redshift, which are SQL based, or maybe a data lake, or maybe a feature store. And we'll discuss about that in the next slides. And then after you get that data, again, how you slice and dice it to data wrangling, it's really up to you, depending on the domain you're looking through. You can clean it, maybe visualize it, make sure it actually makes sense. You have maybe outliers you want to remove. You understand that actually is something that might be working by doing a quick estimation on the performance of that model. And then, if that's something that you like, you can bring it into a notebook, or you can export it for later, or maybe share with your coworkers when you're using the same data to maybe solve different problems. And speaking of that, when you have the same data, but you're looking at different attributes of that, different features, you might want to collect all that knowledge that you have about that domain, about that data, and use it through a feature store such that you can solve different research questions, different problems by going back at that data and looking at the various attributes grouped together in a specific relationship that actually have relevance for that field. So the feature store can be used in both streaming and batch mode, and they can be used to have a more formal process that is useful across more than just one single problem. So when you have to work with coworkers, when you have to work with others, and we always have to go back maybe to original data to see that what you worked on actually makes sense for that domain or for that problem, or you might want to tweak in a different way. I already mentioned that you can use the feature stores in different way, online versus offline. You use the online feature store if you're doing real-time predictions. Typically, you have an application, it could be a website or something else connected to your model, and you are responding for requests coming in, and you want to use the latest copy of the feature data. You have to deal with milliseconds because, again, maybe you're serving a website, versus the offline mode in which you typically use batch predictions. You have a lot of data you want to pass through. Typically, it's historical, and whether it takes a millisecond more or less to start doesn't really make a difference. You still want high throughput for your data. And again, that's where you would use, for instance, the feature store in an offline mode or offline feature store. Let me stop here if you have any questions. For questions, please put them in the chat and we'll respond to them at the end. So I mentioned that SageMaker is based on JupyterLab. This is how it looks like. And right now we are looking at one of the features, the autopilot. And the beauty of this is it allows you to try and tune different machine learning models automatically and figure out which are the ones that give the best performance. And you see them here listed as an experiment. So you can go at each of these and see specifically what made them so performant. You can analyze all what we did in the back end on your behalf in a simple notebook, see why that was performing the best, and again, be able to use it as is out of the box. One problem that you have to remember is that there is bias typically. And creating a solution for that is typically manual with lots of moving parts, lots of open source packs that you might want to string together, which means a lot of custom coding that is hard to scale and maintain, which basically puts it all together as a complex, plumbing that you're creating. Doesn't really give you any benefit per se from a scientific point of view. It's just something that you have to do because, again, that's an inherent part of dealing with the data and machine learning in general. This is where Clarifai can help you. And Clarifai can work across different stages of your development, from the collection side, when you're actually in the initial stage where you work with, for instance, Data Wrangler, which is on a demo, all the way to the hosting of that model in production and monitoring that actually performs as it should be, and seeing that, for instance, not drifting because you have new data or new insights. So as you have the data and you went through maybe an exercise of cleaning it up, and you use Autopilot to figure out, again, what's a good strategy, what's a good algorithm, what are the right parameters I can play with, and you identify some bias and correct it for that. So the last part is maybe going for, now I have some idea, I want to put it in production, or I want to go towards production, but the volume of data I really have to go to is rather large. So I need a lot of horsepower if you want. And in that case, we have an entire set of different machines, if you want, that can help you do the training and the inference. Depending on what kind of machine problems you are actually solving and whether they're traditional versus deep learning, you can use, for instance, just regular machines which have CPUs from Intel or AMD, or maybe our own Graviton processors based on ARM technology. And here you see some examples from the M5 going to R6G. And this can be used both for training and for inference. On the other hand, if you're working on deep learning problems, you typically use maybe for the training part a GPU, such as, for instance, our NVIDIA-based A100 and V100 GPUs, or maybe the T4 GPUs, depending on the specific problem you're having at hand. But later, for the inference part, running the same code, or basically the model on the P4, for instance, D, and NVIDIA A100 GPU, is not the most cost-efficient way to do it. In this case, you might want to use our inferential or the G4DN, for instance, instances, so that you get high inference performance, but at a reduced cost. And again, depending on the problem, you might even run it on CPU. But these are some of the options that you have at your disposal. Looking specifically for very hard or complex computational problems, looking at, for instance, the largest GPUs that you can get in the cloud, You have the P4Ds, which give you 8 NVIDIA A100 GPUs, up to 400 gigabits per second of networking bandwidth. And these are grouped together in ultra cluster. You can get thousands of highly coupled GPUs. This is how you can solve large machine learning problems in computer vision, or for instance, text, like BERT, this is where you play, or for instance, HPC, if that's another field that you are looking for. This can be used for both real-time and batch inference through our SageMaker hosting or batch transformation, depending on the kind of problem that you're serving and whether that is connected to an application or it's something that you use, again, just to go through big chunks of data one time. Both of this, you pay as you go, so there's a model that it's applied throughout with the SageMaker platform. When you have the model and it was working fine and you're thinking about deploying it, one thing that you have to keep in mind is that this is not a one-time deal. Typically, if you work, especially in a team, you have to think about what happens after this version of this model. Is this the be-all, end-all? Typically not. I have to probably create an update, or I want to try a new thing, or a new parameter, or maybe bring in more data. And that means I would have to somewhere have different models I can compare. A and B, is this better than the other one? Whatever that better is. And for that, you use a registry. The process through which you go through different versions of different models, and maybe the pipelines associated with that, have to be formalized and well. And if you're, again, using standard code development pipelines, CI/CD should ring a bell to you, and you can use the same procedures through SageMaker. And then performing updates in which you maybe have already a running model in production and being able to switch to a better performing one and have everything done as seamlessly as possible such that an application connected to the model is not being disturbed. And then being able to optimize your computation, maybe choosing a better performing platform for the deployment, for the training phase, being able to experiment with all of this, and making sure that you're getting the best bang for the buck. And this is where we also help with relation with other vendors. So if what we provide out of the box, the algorithms are there, or maybe your own are not really performing as good as you expect in the field that you're working on, there are third-party providers and vendors that can come in and help you in that regard. And you can easily get access to their respective intellectual property and algorithms through our marketplace, the same as you install an app on your phone. So you can work, for instance, with some of these vendors on different problems. They already have maybe state-of-the-art capabilities with minimal friction. So let me stop here and see if I have other questions while we do a switch to Gang, such that he can do the demo part of this.
Thank you, Claudio. Hello, everyone. Today, I'm going to run a demo using SageMaker Studio, which is a fully functional IDE interface for you to build and play with your data for machine learning project. So now we are seeing this is the AWS console. From here, we can go to different AWS services. Let's go to Amazon SageMaker. So SageMaker, console give you the option. You can use SageMaker Studio or other SageMaker services and module. I will walk through how what the function they can provide later on. We can start the SageMaker Studio from here. If you first come to SageMaker, you may not have the SageMaker Studio domain created. You can just follow the instruction. There's a quick start deployment. You can quickly create a SageMaker domain and add users. So when you create domain, there are two options for you to set up authentication. So one way is using AWS single sign-on. Is if you already have AWS SSO set up, you can go with this authentication, this method. If you go with AWS SSO for authentication, you will have a hyperlink. Go to SageMaker Studio directly, so you don't need to access SageMaker Studio from AWS console. Another method is AWS Identity and Access Management, or AWS IAM. If you haven't set up AWS SSO, you can certainly use the AWS IAM authentication method. If you create SageMaker domain using that way, you will need to go to AWS console to access SageMaker Studio. So in this case, I have AWS single sign-on for authentication. I can directly go to SageMaker Studio from the hyperlink here. Let me walk you through other SageMaker modules here. On the left sidebar, you can see there's a SageMaker ground truth, help you to annotate and label dataset for you to build supervised machine learning model. There's a SageMaker notebook, allow you to start the notebook instance and running Jupyter notebook. SageMaker processing and training and inference. Through those features, you can create separate jobs on SageMaker managed instance. Through Edge Manager, you can compile your model through SageMaker Neo and deploy them on edge device. SageMaker Augmented AI allow you to incorporate human review process in your data pipeline workflow. At last but not least, AWS Marketplace, you can search for algorithms or search for a dataset you are interested in to quickly build your AI ML application. Now let's go to SageMaker Studio. I already have one studio open up here. So this is the SageMaker Studio interface. When you first access SageMaker Studio, you will see this launcher, SageMaker's launcher. It gives you some hyperlink and a button to quickly carry out your experiment on SageMaker. So there are different one-click solutions, models, and tutorials you can play with. There's also SageMaker Jumpstart. And there's a different SageMaker task and components. I will go through several of them later on. Next, let's look at the left sidebar. On the left, you have file browser. You have this running kernel and terminals. You can see which instance are currently used and running. Those instances will be metering and you will pay for them. There's a Git function. You can easily download code from public GitHub repository. You can run command here. You can see which tab are open. There's a SageMaker Jumpstart. Jumpstart have the sample of pre-built notebook or sample notebook for you to quickly run some experiment and get familiar with the interface and functions. Finally, there's a SageMaker component and the registry. Here, you can see there are plenty of SageMaker functions, features you can easily access through the UI. So in general, SageMaker Studio UI extends the Jupyter Lab interface. So if you're familiar with Jupyter Lab, you should feel comfortable playing with SageMaker Studio. So for today's demo, we're gonna look at specific data set on AWS Open Data program. So let's switch gear, look at AWS Open Data Registry. So this is the platform host open publicly available data set for researchers to run experiment and build machine learning model or do statistical analysis. As you can see, currently there are almost 300 data sets available. So we are going to use Mimic 3 dataset provided by PhysioNet. This is a pretty popular dataset. People use it for population health study to build statistical machine learning model. To access this dataset, all you need is this S3 bucket name. So using SageMaker and with AWS Open Data, you don't need to download and upload your dataset. Make it much easier to bring your compute and your algorithm close to the data set. And you can easily share your notebook, share your knowledge with your partner and co-workers. Now let's copy this bucket name. We will do some experiment later on. Let's go back to SageMaker Studio interface. So first, when we want to do machine learning, carry on a machine learning experiment, first we need to get the data, ingest the data. So I'm going to using one of the function in launcher called data flow. So this data flow using SageMaker Data Wrangler to help you visualize how to import data from different data sources and how to massage the data, doing data wrangling job, and eventually get your final data set, a tabular data set. You can run machine learning on top of it. As you can see, you can import data from Amazon S3, which we will use later on, and Amazon Athena. Athena is an on-demand SQL query service. So you can run SQL query to filter and aggregate data set. You can also import data from other data sources like Redshift or Snowflake. Let's look at how to import data from S3. All you need is the S3 bucket address. So this is the bucket on AWS Open Data. I can see there are several files, the GZ file, compressed file in this bucket, and each file can be imported as a table. So let's select one of them. You can see this is the preview of the data table can be imported, and we can import like this. After we import the data, we can either transform it or perform analysis. There are different transform options. You can run custom transform, there are custom formula or other type of transform, like group by or handle outliers. Let's go back to data flow. Another way to import data, you can import through Amazon Athena. If you want to import data through Amazon Athena, you will need to create a data catalog in Amazon Glue. We do have tutorial and introduction to help you easily create, run Amazon Glue crawler job, create data log on Amazon Glue. So I already create the database, Mimic, and there are tables created on the left. Here I can run SQL query. Run a SQL query to generate the table I want to import. Certainly, I can join different table and run group by or filter. I can import and give it a name, the dataset name. And then I will have a different data sort on in my data flow. So after you have different data source, you can also join them together. You can play with different drawing. There's a different drawing option, and you just need to select what column on left and the right table to join together. So that a quick show how to create an import job, a data flow job on SageMaker using SageMaker Data Wrangler. I already created data flow to import data for this specific study, the ICU readmission. So this study is just a binary classification model on top of tabular data. So you can see it can be generalized for any other research use case. If it's classification or regression problem, we can apply it there as well. I already have different data source set up here. I run Athena query to aggregate data. I have different data table and join them together. Finally, after I join the table together, I can add a transform. Here I add a transform running Python script using Panda library. So you can see on the left, this is the Python script. I run through them and clean the data, generate the label. Since I'm going to build a supervised machine learning model, I'm going to run the script and create the label. The label is the future red meat. Let me see if I can make it bigger. This is the script. And finally, I generate the label for this data set after using this custom transformation job. And this is the final table. How does it look like? And from here, I'm going to show you not only we can perform transformation on data set, we can also perform different analysis. So there's a different way you can add analysis. You can add analysis after the join. There's a plus sign, click the button, you can add analysis. You can certainly create like different plot, histogram or other. Here I'm going to show you to run a quick model. And you can select select a column as a label and perform the data analysis. Let me see if I can get the final data node. Yep, this one. Since this one, I already generate the label through the custom transformation job. So I'm going to perform a quick model analysis and pick up the label I generated. Future readme is a binary column, yes or no, and generate a quick model. So this is pretty helpful if you doing data exploration. You want to know which data feature correlate to your final label. You can do this iteratively and help you to quickly generate feature engineering pipeline. So while it's running, I'm going to show you from the data flow, we can also export the data. Well, it doesn't allow me to export data right now. Look like we can only wait for this job to finish. Usually take a couple of minutes. It's based on your data set. It pick up the model that can quickly be trained. Usually it's a tree-based model and give you some statistics and graph representation to let you have a general idea which feature correlate the model output, the future model output well. So while we are waiting for the job, yep, look like the job finished. We can also look at the tabular data. So you can see each column. We want to see the column correlation with the final label. So here's the report of the quick model. You can see it built a random forest model and give you a F1 score of over 0.7 on test set. And here's the feature importance to build this model, binary classification model. Let's go back to the data flow. So after you build the data flow, you can export it. There's a different destination you can export data to, export this data flow to. So your data flow, you can export to S3, means after you run the data flow, the final data set, the data table, will be exported to Amazon S3. It's an object store. our file store. You can save file there. You can easily read the file into your notebook, or you can export the data to feature store. That's another SageMaker module we have learned earlier through the presentation. Let's say if we click on Save to Amazon S3, it will automatically generate the notebook, Jupyter Notebook for you. All you need to do just to run through those notebooks. So it's basically the data preparation and the feature engineering steps. You can run through them and finally load the data. You can either load the data memory and look at the data. And you can also export the data to S3. I already have Jupyter Notebook I exported earlier. It's the same notebook, but I ran it earlier since running data processing job takes some time. So this notebook, the same notebook I have run earlier, you can see those cells, notebook cells already been executed. And we can see the processing, the data wrangling job has been executed. There's a logs available. This is the data processing job log. It's basically run through those query, drawing data table, and perform transformation, and finally get the output data frame. So after run through this job, you have an option. You can load data into pandas and look at how the data frame or data set look like. So I already ran through those cells. Again, this notebook automatically generated. You can easily play with them, or just to run through them. You will see those results. So this is the data set look like, exactly look like what we have seen in the data flow table preview. And this is the label, the binary label. And from there, we can set up machine learning job. So for this specific use case, a tabular data set, classification, binary classification model, we can use SageMaker Autopilot. It's our AutoML function. So it's in the SageMaker component running experiment. So basically, we create Autopilot experiment. All we need to create Autopilot experiment is the location of the final data table we prepared. So I run this cell, it tells me this is the S3, the final data set located. I just copy it. I'll copy it, and I will use it to create Autopilot experiment. I can give it a name, let's say test4, and the data come from S3. I provide the S3 location. This is the S3 location. I copied over from the notebook, and select the target column. That will be the future readme. And finally, tell where to save the AutoML result. So I can find a S3 bucket and give it a table folder name, and we can create a job. You have an option to automatically deploy the model in production after finding the best performed model. Let's turn it off. We don't need to deploy model. And then we can create the experiment. So as you can see, creating AutoML experiment, there are several steps to run through. It will pre-process the data, generate the candidate definition, running feature engineering, and find the best model and procure the model, and finally get the model explainability report. So this experiment takes some time to run. I already have job previously finished. Let's look at this. So this test 4 is we just created. Let's look at test 3 then. So this one I already executed, and this job I have been finished. So it runs through several jobs, as you can see in the previous page, and find the best model. So, and if you're comfortable with this model performance, you can just click on deploy model, just one click, you can deploy this model running in production and ready to take request for inference, taking inference request. Let's look at the best model, the model detail. So you can see in the model detail page, you can find model explainability, artifact, and other information here. For model explainability, what we usually want to see most will be which feature contribute most to the label, to the target label, right? So this feature importance come from SageMaker Clarify, the sharp analysis. So you can get the feature important analysis here. You can get different metrics like AUC, accuracy, F1 score for the to evaluate the model performance, and also the hyperparameter to train this model. So this model here you can see model status completed. The algorithm used is actually boost, and it's a binary classification problem. So from here, you can readily deployment just one click as well. Now we have seen the walkthrough and demo using SageMaker Studio. Let me get back to the slide. We have used SageMaker to carry out different experiment, building prototype project to show the state-of-art possibility how people can use SageMaker. So one of the projects we have shown in the blog post, the hyperlink below. So this blog post, we use SageMaker ground truth to annotate medical images. So usually medical image has a standard format, DICOM format. So through SageMaker ground truth, we can visualize the medical image in DICOM format. We can annotate them, either create a bounding box or label, and output the result, the label result will be saved on Amazon S3, and we can read them on SageMaker Studio notebook, create classification or segmentation model from there. This is one example. Another example to show people want to see the real world application of machine learning model. So one of the application is we can use machine learning model to transform unstructured data like free text or image into structured one, like a vector. We call it feature vector. So using deep learning model, we convert the unstructured data to structured one. We can save them on AWS. Here we use Elasticsearch, the search engine, and we can build a search interface, allow people to search image they want based on the text or similar image. Again, this study also, we have a blog post, and all the code are open source, is on GitHub. Feel free to take a look. With that, I would like to conclude our presentation today. We'll be happy to take any question. Thank you.
Thank you, Claudia and Gang. What a wonderful presentation. And we do have an inquisitive audience, so I'm going to jump right into questions. First question. We have deep learning models running on a workstation with GPU that makes a prediction on each page of a 100-page document. How can SageMaker make the predictions simultaneously in a 1 to 100, 100th of the time?
Right. For SageMaker inference, you have learned through the presentation by Claudio. The inference is a manager's job. You can configure it either running through a batch inference So you can submit a job, say I have 100 files or 100 image or different file format. You can run batch transformation. There's a SageMaker SDK API function allow you to invoke the inference for batch job. You can also run online inference. So for online inference, the request will take in sequentially. However, you can easily scale up your inference endpoint. Since it's managed inference endpoint, so you can through SageMaker say, I want to deploy multiple inference instance. That's possible, and that can speed up your online inference job and reduce the latency.
Wonderful. Next question. We start with pre-trained BERT models and then retrain with our corpus and then use those. How can we do this with SageMaker?
So on SageMaker, I have to show you, you can use AutoML or other SageMaker built-in algorithm, but certainly you can also bring your own algorithm. Let's say you have your deep learning model, the BERT for natural language processing model. Your model may have a specific runtime and library dependencies. You can create a custom container, and on SageMaker Studio, you can just bring in your custom container without the runtime and library, and bring in your own algorithm and run it on SageMaker Studio.
Great. If we have an NLP app involving several deep learning steps running in AWS on EC2 instance with GPU, what is the best way to redo it to run faster, to be easier to maintain support CI/CD, and improve it by running experiments to improve the steps?
Yep, we have a different service function to orchestrate data machine learning pipeline. As you can see in the presentation today, SageMaker has a SageMaker pipeline. If you want to run your job on SageMaker, or if you have already containerized your runtime, you can run it on AWS Container Service. And we do have orchestration service to help you automate the job.
Great. I have a very complex problem with significant data available that I think a machine learning solution can definitely solve. Who can I contact to discuss my problem, get a suggestion on how to proceed? If you guys will email us at that AWS-WWPS-seminar@Amazon alias, we can go ahead and find your dedicated account manager and solutions architect and have them get in contact with you to support. So I'm going to move on to the next question. Does the Quick model use PCA or some other underlying method?
Right. The Quick model depends on the data set you have. For majority of tabular data, I can see is using random forest, the tree-based approach. If you have specific requirement, you want to run PCA or other analysis, we can definitely help you to see how this can be performed. Personally, I have not run it yet, but I would be happy to take a look how this can be done.
Great. Can I bring my own TensorFlow model into SageMaker?
Certainly you can, yep.
And can you speak, oh, sorry, go ahead.
I just want to comment on that. We do have a pre-built container runtime for different deep learning platform. TensorFlow certainly supported, PyTorch, MXNet, or other data science runtime, Python runtime. So you can either use pre-built one, or you can bring your own container.
Great. Can you speak more about open data and what is available?
On open data, let me see if I can go back to the open data registry. Here, you can easily search and find the data you want. The data set have a tag, so you can see there's a different tag available, and you can use tag to group. Let's say I want to search data for genomic, all the data with the genomic metadata tag. There are 57 of them. And the data are certainly growing. So this open data community, we have seen more and more data available out there. If you are specifically interested in some open data, feel free to let us know. We will certainly work with the data publisher to see how to bring the data on open data.
Great. Well, I want to thank you both again, Claudia and Gong, for such a great presentation, and thank you to our audience for attending. You can find information about upcoming sessions as well as recordings and presentation decks on our series homepage, which I placed a link to in the chat. If you have questions about past presentations or ideas for future presentations, please email us at that aws-wwps-seminar@amazon.com alias. Our next session for the AWS Education Research Seminar Series will be non-contact biopsy using machine learning and optical coherence tomography to create a skin histological image without cutting the patient, with Dr. Jonathan Weintraub, BioX Fellow at Stanford University, and that will be on October 25th from 9 o'clock to 10 o'clock a.m. Pacific Standard Time. And I also placed a registration link to that session in the chat if you would like to register. Before you leave, please take a minute to give us feedback on today's session. A short survey will pop up on the screen as we close out. We host these webinars for the research community, so any feedback that you have is valuable and will help us to continue to deliver content that the community cares about. Thank you so much for joining us today, and we look forward to seeing you again soon.